Node core concepts. We're going to look at we're going to look deeper into some things we've already learned in fundamentals, but basically this is a core concept meant as a review at the end, but also some processes where some things like the process object we'll be digging deeper in. What are the core concepts of Node? All right, so we went over this one before, but it could be reviewed. So we have a global scope object. So we have a couple of these things that are defined for us out of the box that give us some really nice functionality. And so these are the things that we have right here. So in contrast, browser JavaScript, vanilla JavaScript that exists in the DOM and browser by default puts everything in a global scope, right? That's pretty bad. We get used to it that things can pollute the global namespace, but we do have those APIs that kind of give us some type of way of organizing these things, like a window in the DOM and document model and these kind of things, right? Those APIs. However, when Node came out, wanted to behave differently with everything being local by default, so that we also have the modules and all of that based on CommonJS and all those things to protect our namespace so that we can pull things in when we want, so on and so forth, right? So when we need access to these global objects, there is, in fact, a global object that we can use. And you've already probably have gotten used to this by using such things as the console. Console, if you notice, is a capital C, not lowercase window.console that we know. It's used to print a standard in and standard out. Again, it's just another wrapper around these things, but it makes us feel like JavaScript. A couple other things we may have run into already is that double_ file name will give you the code being executed, where the file is, the directory name, so the name of the directory that the currently executing script resides in. So we've probably seen those when we were doing Express and serving up our static site, building static assets and those kind of things. Those helped us out quite a bit. And then the timers. So we, again, already know these, but this is pretty useful, especially when we're doing this asynchronous approach to Node.js. Same deal as the browser. I don't need to go over those, but okay, well, maybe I will, because they're here to set timeout, has a callback. You set a milliseconds, and it basically will run the callback after that certain amount of time. Clear timeout, you can make a reference to that timeout variable. And if you want to clear it at any time or stop the timer, you can basically use that. Set interval, it works the same way as set timeout with a callback, but it basically repeats every 5 seconds, for example. It'll just keep repeating. Remember, those delay execution, right? So, sorry, not delay, they defer execution off the main running thread onto the call stack. If you recall what the event loop looked like, we could defer execution to a later time. Console object, like I said, it basically is standard in, standard out. And then we have a process object, which we'll talk about in a little bit. So this is used to get information on the currently running process, the process that is running your file, your script. If you recall with the files, we can change directories, change where the process is running. So if we needed to change the current running process somewhere else, meaning maybe we needed to go to a different partition of our computer, right? We're on C drive in some location for Node, and we want to change the entire running process to go on the D drive or some other kind of other drive and make some changes there. We could certainly point towards that if we needed to, right? So these are global scope and objects. This process object, which we will review again in a little bit, has a whole bunch of things related to it. So this is one of the few global objects provided by Node. So you can have access to this anywhere. Thus, its methods can be accessed. So if you need to access any of these things from anywhere, you don't need to refer it in. There's one important one called process next tick, which we'll get into in a bit. It actually allows a callback to be scheduled for the next iteration of the event loop. Every time you go around the circle in the event loop, that loop, the circle, the loop, it's actually called a tick. Right? That's what they call it. Think a clock, tick-tock, right? Some interesting things on this process object is you can get now these might not be very interesting to you. For instance, the process ID. Why would I want that? Well, when you get into scalability, you might want to know which process you are working with, or in fact, if you spawn child processes, which process you may want to destroy. You may spawn a process that runs, and then you may need to destroy it. But you don't want to destroy, or if you use kill, all child processes, you want to make sure that you are destroying the correct one. Saying, for example, you had a process that goes off somewhere and it does some high computation and it can send a signal back to the parent. Maybe the parent knows which it has many child processes. It needs to know that this ID is actually doing that big transaction. Therefore, if he's giving me the signal back, I can quickly do an update, a lookup, and say, okay, I'm going to terminate that running process. So that ID is actually useful in those situations, but you guys haven't worked with that, so it may be really far out there right now. Process standard in and standard out, and standard errors. Think of console, standard out, reading from so we're talking about the command line. We can read in from the command line. We can also output errors to the command line as well. And then also this process argv. So that's a way that you could read command line arguments off the command line, so that if somebody was typing commands in DOS, to actually run Node.js projects, if we wanted to run, I don't have it here, obviously, right? If I had menu, and then I applied, a number and, whatever it is, right? Or maybe we have some backup.js, and we want to back it up for 100 files, and we want to terminate it after 50 minutes, right? We can pull in these parameters in the command line and use them within backup.js if we wanted to. So we can pull in from the command line if we didn't have an interface or anything like that running off a web server. A web server, we could just basically have server specific applications, right? Which we may have a need for whatever reason. Some other things on this process object, some other methods was the CWD, like we showed in the node file system. You want to change the current working directory. I want to create a backup in the current running directory, which is where I'm running the script. But however, I need to go into the log folder. I need to delete everything in that folder, switch the process back to where the script resides, and then delete the log folder, right? So we can do that with the CWD. And then process.kill. So that would be a situation where I told you maybe about spawning, or maybe there's just another process running. I don't know if you guys ever I forget the command exactly off the top of my head, but I think it's inetserv. In that folder in Windows, for instance, you can get a listing. I forget I use it every day at work. I usually have it saved. You can get a list of the running processes, right? What's running and where they're running. Maybe you want to kill one of those processes. I don't know what it is. Maybe it's IIS, or maybe you don't want to do that. Maybe you want to put something like that, right? You could terminate something that's long running. You can look up that process ID and then send a kill command, a signal to that process with an indication of what you wanted to have happen, the signal, and then if it's listening, you can terminate it. It'll terminate itself. How much memory the process is using. Change the process directory. Okay, sorry. CWD, the top one, returns which directory we're in. Change CHDIR changes the process directory. And then you have information on the uptime, and then of course the next tick, right? So this is all in a global object. Has a couple events on it, which we'll go over again when we look at the next session. But it does have interesting events on it. That again, it's an instance of event emitter, and everything derives from that events emitter. Emit the following event for this process. when it's about to exit, when or just be sorry, when it was about to exit, before exit, emitted when node empties all of an event loop and has nothing else scheduled, you could tie into that. If there's an uncaught exception and an exception bubbles up, you may want to capture that all the way back to the event loop. Signal events. So this is what I'm talking about. So processes can send signals to themselves. It's pretty cool. You can actually kick off some different things, and then you can listen for different signals, like an interrupt or a signal hang up. You can have a lot of chatter going on amongst processes, and it gets interesting. Here's a little setup as you would normally set up. You set up a listener. Okay, the process is listening for when it's going to exit. Following code will never execute. This will not run because it's about to end. Yes, this is worth noting here. So, do I get this? My pointer. So what this is going to show you here, and you can visualize this. This would basically defer execution. This would be one of those things where, and I ran into it on the day job. I was trying to do, if you recall, I was trying to back up something from the search engine, the search product list. It was a JSON file, and I needed to upload it to Azure, right? Maybe I can share that code if I remember where it is. I had a whole bunch of logging. There's like a third-party logger tool. But for some reason, the logger was not logging. I didn't understand why. Any errors, if there was an uncaught exception, the logger would not fire. So we had no information on what was happening in this third-party logging tool, because I think what was happening was on error, some kind of errors, right? Error handler. It would do process.exit, and then we would try to. I think what would happen is we would log, fire something to the New Relic. It was called New Relic logger, and then exit right away. The problem is the New Relic agent. There's an agent running that handles the logging, didn't have enough time to close gracefully. That's what they would say, right? We needed to give it time to close up. So I can't remember how we handled it, but I believe we had to tie into before exit, I think. Try to shut down this agent properly, wrap it in a timeout, something like that. And then after that, after it closed, I think it was inside of when the agent closed down, it returns back a promise. Only then would we exit the process, because what was happening is when this process exits. Like it exits, this script will never run because the process is dead. If that makes any sense. So anything that happens after the fact that the process is closed, that means the script, anything executing there, will also terminate. So if you have a lot of things that are happening after that event, they're not going to fire. So it's very interesting. So there are ways that you may need things to shut down before the process terminates, and you may need to trigger into that. So will the event listener still be triggered if the program crashes? That's interesting, because we should, if the process itself crashes, we may not get a graceful exit. We may get one of these uncaught exceptions, right? That may happen. So it may not exit exactly cleanly as what we might expect. So sometimes from the inside of our code, we may not get some indication of what's going on. But hold on to that thought. I know when we get into child processes, there's ways of terminating from the outside and then capturing the guy, like it failed, with some indication of what happened to that process. There's some code to let you know that it did fail. This is the reason why it failed. And you can inspect that from the outside of that process, right? Now, if it's executing the script within that container process and the process dies, maybe the script won't complete as expected, right? However, there's always a fingerprint or a footprint on these things, right? They don't just die without any indication. There is always some indication. Now, whether that's listeners on the outside of the process that can keep track of that in the system, right? They may be able to keep track of it, but the script running inside of the process may potentially die if the whole thing terminates, right? But it's a good question though. And especially when you're dealing with multiple processes and you know, it gets very, very confusing sometimes, right? What's happening where and when? Did I terminate and close when I needed to? Did all these signals fire before as I expected them to fire? I know for myself, when I was debugging that portion of it, I couldn't figure out for the longest time why the third-party logger was not working. I just didn't get it because the process terminated before the agent that logged had a chance to even do its handshaking and send the message down the wire, because it needs to do a few things in its own encapsulated logic, right? That's a lot to say. You take a drink of water after that one. Modules. So this is another core concept of Node that we can recall from Fundamentals 1, a way of encapsulating our logic. Whether it be express routers, whether it be our own custom modules, whether it be a handler for Socket.io, whether it be Mongoose models or connectors, whatever we may want to create little packages of, we can. We don't necessarily need to have everything running from our main file. We can, but it makes for a very long kind of, 1,000, 2,000 line file, which is not uncommon, but sometimes for clarity and reusability, we may want common logic placed somewhere else. Because it's true, bad part of JavaScript was there's no way to include modules, right? Node was written pre-ES6. And again, in vanilla JavaScript, prior to some of these updates in schema, they didn't really have there's a way of including modules. So there are so many patterns out there that I learned prior to even like closures or different classes and things like that, or named functions. Patterns of wrapping objects, logic inside of a giant object literal to give it a namespace. So if you had header dot, whatever, hide this control, hide that control, you could separate things out in that way. There's different ways to solve that problem, but anyhow, so Node didn't want to worry about that stuff, right? So they, inspired by Ajax and how they use the CommonJS modules. As you recall, when we had that, when I showed you that the video of the creator, Ryan Dahl, he was like, at that point, that was like 2012, I imagine. CommonJS was just coming out, and they're like, yeah, we may take that some of those best features from them. They were undecided, but obviously they incorporated this kind of approach, right? So if we want to create a module, we create it, and we need to export it to the world. We use exports. And basically, after we do that, we can import it using require. So we've already been through that. But another approach is to invoke a constructor when we attach properties in express.js app. So this is basically just showing how we could bundle up some engine to set up. It looks like we're setting up a port. Now here is that global process object, right? This is basically just saying, okay, is the current running process, does it have something called an environmental variable? Environmental variable that has port. So we can attach different things to this environmental variable if we wanted to set it, let's say on production. If it exists, use that, because we may be in an environment, and that environment port may be different on your QA box, your staging, your production. Otherwise, if there's none existent, then default to 3000, which is our local host, and that's a way to use the process object right there. If you notice, it's just called without any reference or importing from that. And then this goes and sets up, and you see right there, there's the other common one, the dir, the directory name. So it builds the views. Okay, where our directory, say it's C drive blockchain /views. So there we know where to look, and then sets up. does the pre-configuration. So what this does is it takes in Express app, sets up everything. So it does the configuration. Maybe this module would be called, setup Express. Return the object back that has all these configurations in it. And then this is how we would set up. Here's Express defined. We pull in our configuration, which is this, in fact, just this right here. And then we just pass app through, and then we reference it again. So basically this object by reference is going into this module. It's getting all of its properties set. And then that object, that reference is being assigned to the one that in this scope called app. And it's good to go. So we can we could take some of that code out of here. Of course, we could have all of this underneath here in this place here, and it would work just fine. But that just shows how to quickly use that. Another thing to note if we're reviewing is, by the way, if you had a folder, well, I'm trying to think now. When you're requiring, it's going to look for the module name, and if it finds in that folder an index.js, it'll know to look for the index.js, right? Like, in fact, we could have just done /config. I forget how you call that, but it'll actually traverse up to that folder and look for index if it finds it there. I don't know if we did an example there that you can actually use an index.js file to you can have, say you have a generic module that is like a shared module, and you have inside of that module you have something like a calculator and utilities, common utilities, right? But you don't want to require every single one of them. You can have an index.js file that exposes all of them. So inside of your index.js, you require them and then you export them just as an object. So if somebody were to call that one file, they would have the whole thing, if you get it. They don't have to do 10 different imports or requires. You could just do one and get the full object back that has everything it needs inside of that main object, if that makes any sense. Different patterns for different scenarios. This one we talked about last class, the buffer, another core concept of Node. So it's in addition to Node.js, we already talked about the 4 primitives. We have Boolean, string, number, regex. So now we have another one called buffer. It's a data store. As we mentioned, it's like a bus stop as the buses come in. As the data comes in, the data will come in as chunks and serves it out in like a queue fashion. So it doesn't try to fill it up. So Node.js will try to use buffers anytime it can, reading from a file system, receiving packets over the network. Anytime it can do streaming or anything like that, it'll try to use a buffer. We already saw in the example last class where we were streaming a video. We were streaming a movie trailer, right? And I just did that from my Node.js localhost. I didn't download it all at once. It just, when I clicked play, it just was sending those bits really quickly across the wire. File system was the other one we looked at. Reading from the file is done via the core module, the core FS module. 2 method types, async and synchronous. Most cases we probably want to use async methods, right? I don't know, unless we really wanted to, have prevent some callback hell, and we had a very simple scenario that we wanted synchronous things. We have that option for that situation, but for the most part, we may want to run things synchronously. So here would be how we include it in. We use that built-in method, require fs. There's another one. We can include another module for path. We're going to read a file, and there's that global directory name. So we're going to read a CSV file. It's been a while, CSV. So CSV, suppose you had Excel and you change it to a comma-separated file, comma-separated view, right? Some encoding, there's the encoding format, a callback, console log it out. So read everything from the CSV, console log it out. So we didn't actually play with CSV files, but we just did text files, but well, we can read any file we want. Same deal if we want to write. The same way if we wanted to read everything in. Well, we haven't talked about piping yet, but if you recall, we could in fact read everything from the CSV with a stream. We're just looking at files. Maybe I'm stepping ahead too much, but we could link these two together. But if we didn't know anything about that, we could just write to a file. This writes to message.txt. It basically will put this hello world in there, and then it'll give us some indication when it's done. If we want to link these two together, we have this data stream. So streaming is a term that means processing the data while we're receiving it. Streams might not be available at once. They don't have to fit in memory. So not everything has to fit inside of that. If you remember the example of downloading a 600 megabyte file, normally it would download, and we saw the time on that. Whereas if you stream it and buffer it, it was like much smaller, right? It was like 40 megs because it'll keep serving out that 40 meg chunk instead of the large data set. So if you want to use a large binary data set, and remember everything will be binary, like data, video, data, or these things, you can use these buffers, right? Node by default will use buffers for streams. And it looks like this. The data is being chunked in. Sorry, these chunks coming in. As it's being served in the buffer, it's being passed on and processed. So this would be called the stream. Like a bucket, the buffer is like a bucket, and this is a stream of water, right? We can also pipe this water stream into another direction and redirect it if we needed to transform it. We wanted to do that. I'm jumping ahead again, but yeah, to our point, here's a file we want to read. Read file will put the whole file and content in memory before writing out the response. Memory consumption on this read file will jump over 400 megabytes of memory. But if we use the streaming effect using the similar method, but we'd be using something called a read stream. So those are the difference between the two. So read file will take the whole 400 megs, create a read stream, chunk it at a time. We don't buffer it all in memory all at once. We just basically chunk it out. So the memory usage using the read stream was 25 megabytes. Memory consumption for reading that whole file, 400 megabytes, right? All right. So in this example here, you can see flashback. We have the FS module here. We have the server. We're creating a web server using this HTTP built-in module. And then we're listening on the request coming in. We're going to read a big file, and then we're going to send it back. A bit of heavy consumption there, right? So just want to make sure mics are off. Sorry, I just heard something in the background. Forgive me. All right, so that data streams, and then, oh, we're getting into a lot. So stay with me. So data streams. Next, we want to avoid this kind of thing, callback hell. Now, you may end up getting into this kind of, you may get into this type of situation, or you may inherit code, like in my situation where I was in callback hell. And this is what it looks like. Really how the code will look, it would be that indentation here to kind of let you know what's going on. You'll have this kind of Christmas tree effect, right, going on. As long as we have two space indentation, callback hell is nothing to be afraid of in Node. You shouldn't be afraid of it, I guess. I mean, it's just you need to have very verbose logging to know what's happening. Like, and what verbose logging means is some indication of which callback is firing, right? So at least this one has the courtesy to say, all right, you know, an error has occurred, all right. Or for each file, we're going to run this function. We're going to output the console file name so we know what file we're working on. We're going to get some size on it. If there's an error, we're going to actually output where the error happened. Otherwise, we're going to output the next step, file name plus these values. there's another for each callback function, but at least we have some very verbose logging. I had to do this with that backup tool, the Azure backup tool, because I inherited many steps of callbacks. I had to put a lot of logging in. Then I understood what was happening. I identified where the problem was, and I'm able to debug through it, right? So, the point is, you're going to work in that. It's not to be scared of. But ideally, if you're writing from scratch, if you have the time, if you're happy with using promises or callbacks, use one of the util methods to promisify things or get a package. If you're comfortable to use a sync await, even better, right? However, all approaches work, and there's nothing wrong with that. Just think about your maintainability over time. That's all I can say, especially for the next developer who may pick it up, right? We should try to simplify things with event emitters, promises, or using a sync library. So if there are other ways to break this up, maybe when, if I were to look at this, what would be a better way to break this up? Well, for sure, maybe async or promises. I'm trying to think of event emitters right now, but this one doesn't necessarily like delete or do some of these things that I might want to listen to. So anyhow, you may want to think about that. All right, so that was kind of like review. Now we'll get into the event loop revisited. So this is what the event loop looked like. Simplified version of the event loop. And so Node.js is an event-based platform. Everything that happens in Node is a reaction to an event. It's event-driven, much like front-end JavaScript, the event-driven paradigm. That was the idea. We already know it's powered by libuv, and that whole library in itself that has the event loop. A transaction passing through Node traverses a cascade of callbacks. Yes, it does, it is single-threaded. Event loop. This is handled by a library called libuv, which provides the mechanism event loop, right? We have requests coming in, blocking IO tasks are pushed onto the thread pool, which is a C++ thread pool. Blocking tasks, response, in the next iteration again, it's going to try to pass some of these things onto this queue to serve up, and then pop it off the stack, serve it back, right? That's a very simplistic view of the event loop, right? So the question was, if you're using some text editor like Vim or Notepad, the indent doesn't help. You are too right. Yes, it doesn't help. Sometimes we're referring to this kind of callback hell, right? If you are not using something like Beautify or Prettify or some of these extensions that help with some of this, it will all end up being in one. It'll all be in one, margin, and then it's an awful experience. But let's dig deeper into the event loop, because we only really talked about it from a high level. So there are some very big misconceptions about it. The event loop runs in a separate thread than the user code. It's a misconception. There's only one thread that executes the JavaScript code, and this is the thread where the event loop is running. The event loop is something like a stack or a queue. In fact, when we generalize it, we do picture that, right? And we kind of talk about it in that way. But when we dig deeper into what the event loop is, this whole thing, the event loop is in fact a process that has a set of phases with specific tasks that are processed in a round-robin manner. So when we load things up on that callback queue there, it does go through some process to figure out which tasks go first, which ones go last, and the priority of these things, right? There are rules around it, around which things that it can run, how many it can run within that interval. This is what it looks like. So the event loop has phases. right? So we have a phase that looks something like this. So when we go through, you'll see here timers will be up front. Timers. So everything like a set timeout, a set interval. So everything that is scheduled via set timeout or set interval lives here. Then we go to pending callbacks. So any callbacks we may custom code or event emitters, we'll try to process those. IO callbacks, all code in Node.js is a callback and process here, right here, right? Then there's a phase called idle and prepare. It's used internally. And then there's another phase called poll incoming connections. So IO polling polls for new events to be processed on the next run. And then there's a phase called check. So this is where set immediate callbacks are run here. So if you notice, you would think all of the timers, like including set immediate, would be run here, but no, it has a different phase for set immediate. And then close callbacks. This is where all callbacks are called. All close callbacks are called. So all your events that are listening, like socket.onClose, this is where it will do it in this phase. Now remember, this would be a tick. One loop around, it goes through all these different phases before it does the next loop. So this is what one loop, I guess, would look like. One loop, ticks and phases. So I'm calling it iteration. Iteration. I'm trying to name what I want to do what I want to call that loop. We'll call it, I forgot that terminology, iteration of that whole loop. It's called a tick. Each iteration of the loop is called a tick. So we have phases here. So you can see here all the queues that may happen, timers, IO callbacks, polling, set immediate, close events. And we have the next chunk it serves, right? So it goes through all this. There's a lot of internal work that's going on. I mean, does it impact, your work? You may do custom callbacks, probably not. You defer something on the timers, they get served up pretty quickly. The close events happen, kind of where they should, right at the end of it. Set immediate, though, is a little interesting, right? It happens after a lot of things happen right before close. That set immediate gets processed. I guess that's the recurring task, right? I guess it's meant that it's running on a schedule. Is like a scheduled task. It could be running indefinitely forever, right? Unless somebody terminates it. So maybe the priority of something that runs all the time, the priority of it is much lower than something that would be more immediate, like a request to open a database connection, perhaps. So that is the event loop. Express revisited. So we have built an Express website. We know all about this, but we'll revisit it. It's a good review. Express based on Node middleware module called Connect. So it's based on Connect middleware. That uses HTTP module, so any middleware which is based on Connect will also work with Express. So we may have Node.js sitting in the background here. We have this other middleware here for the HTTP. We have this middleware for Connect, and on top of that, we have Express. As we recall with middleware, it's a pipeline. If a request comes in, we have different things that we can intercept that request with. If you wanted to transform, add some, body parse it to the incoming request, add some security authentication to it, maybe do a check. Maybe we have our own custom middleware where we check that there's a token. Maybe we reject it before it even hits Node.js. Some advantages of Express, hopefully you already have realized in your work with it. It makes the web application pretty easy, right? We already know now when we actually make the setup for the server, it can do it in like 3 or 4 lines. In contrast to the boilerplate code that we had for creating a web server, which is 30 lines long. Easy to configure and customize, define routes. So we can give a prefix to all our routes. We can use the router. We can organize them because you may have a lot of routes. So you may need, not only that, you need to deal with the verbs. get, post, update, patch, all these things, it handles it for you. Includes various middleware modules that you can perform additional tasks on the request and response. Like we said, the middleware is a pipeline. We can add it. We can add a lot of different things, even just very simply timestamping our requests incoming, timestamping our responses. We could easily add a custom function that ties into that middleware. You can integrate it with these template engines like Jade and EEGS, Pug, and these kind of things. Some nice error handling middleware, static files, right? So on our project, in our lab test, we needed to serve up static files. It helps with that. RESTful API, that's what we're after. And easy way to connect with databases, right? We focused on MongoDB. You could connect with, I showed you how to do a simple connection and query against MySQL. We didn't connect to Redis though. I don't know if I have that example, but anyhow, what Redis is Redis cache. It's a caching. You may want to put a caching layer in place of in front of your application to handle various, common things like, okay, I don't know, maybe there is maybe there's some list item data that you need on your screen, stuff that doesn't really change very much. Why go to the server and make a big request and query the database for something that doesn't change too often? You could set a policy on the cache to refresh maybe every week or something like that. If someone makes a request for it, it gets cached in memory. So the next person who makes a request gets what's cached in memory, so that we don't have as much traffic to the host server, thus saving us a lot of performance and cost, right? If it was a public company like the one I work for, they have a lot of Redis in front of it. Sorry, Redis they have many layers of caching. They have Redis caching, and sometimes I get confused myself. Redis caching that lives on the server, and they have Akamai caching that lives in the front end. And there's so much caching going on in my mind all the time. I got to turn things off most of the time. Redis, the note was Redis is faster than MongoDB. It can be used as a task queue for sure. For sure, you can use it. But if you want to persist data, like truly persist data, you're not going to be truly persisting it in Redis. Especially if you have disconnected systems that don't have that Redis cache, right? I mean, but for sure, if you need to fire and forget or put like tasks in there and things like you can utilize Redis very heavily, and it's great. However, remember, if you're dealing with if you're ever debugging and you have problems, turn off your local cache. It saves your life. Yeah, those are the node concepts. I'm going to stop recording right here now because